Welcome! In this video, we'll be learning about functions and graphs. Functions are probably the most important mathematical object you'll ever learn about, and you probably will spend most of your mathematics courses talking about functions. Functions come up all the time in the real world. Let's start by talking about the definition of function. A function is a correspondence between two sets of elements such that to each element in the first set, there is a corresponding element in the second set, and there's one and only one of these elements in the second set. The first set we call the domain, and the second set, the ones that correspond to the first set, are called the range of our function. We usually denote functions by y equals f of x. The way we read this is y is a function of x. In other words, we input x into a function and we get some output value y. This is what we mean by y equals f of x, or y is a function of x. Let's consider an example of a function. My function box here is denoting a function f of x. I'm going to think of a function as a magic black box, or in this case a brown box, in which you put in an input and the function gives you an output. So what I mean is we take an x, we put it into the function, and out comes a value, f of x. I'm going to have my student Victor, who's here with me today, help me out. Victor, say hi to everyone. Victor, what number would you like to put into the function first? Let's input the number 1. So we put 1 into the function, and out comes the number 2. So f of 1 equals 2. What number would you like to try next? 3. Let's try f of 3. We put 3 into our function, and out comes the value of 8. f of 3 equals 8. Let's try another one. How about 6? We plug in f of 6, we put it into the function, and out comes the value of 5. f of 6 equals 5. Let's do one more. We're going to plug in a half. We plug in half is my input into my function, and out comes my value of 7. f of a half equals 7. Let's try one more. What would you like to try next? Panda. Oh well, let's give it a try. f of panda, we put panda into the function, and out comes tiger. f of panda equals tiger. This is my function f of x. Let's go ahead and look at some of its properties. So you just saw my function box, f of x. Notice I put in several numbers. I put in 1, 3, 6 and a half. Those are the numbers Victor gave me. And out came the numbers 2, 8, 5, and 7. Let's ignore the panda turning into a tiger for right now. We can denote these values in a table, as you see on the graph, and we can also depict it as a graph where we have the x and y axis, and we denote each value of the function as a point with the x input and the y output. Let's look at a new function, g of x. Let's try a couple inputs to see what this new function does. Victor, let's put in 1. When we put in 1 to the function, the outcome is 1. Let's try another one. We plug in 2, we get 2. Let's try 3. Let's put in 3 into my function. Out comes the value of 3. I just think I see a pattern here. We put in 7 into our function. What comes out? We get another 7. One more. Plug in 8. Have you figured out what's happening yet? We plug in 8. Out comes the value of 8. Let's take a look at this function. You notice it seemed to have a pretty strong pattern. Whenever I put in a 1, I got out a 1. I put in a 2, I got out a 2. Every number that I input seemed to be the same number I got as an output. You might guess that if I put in 100 to my function, I'd get 100 out. Over here we see we've got a table of our function values that we tried. We also have plotted the x and y values, the inputs and the outputs, on a Cartesian coordinate system, or the xy plane. Let's think about this function. Do we know which function this one is? Well, you probably guessed it. This is the function g of x equals x. For every x value I put in, I get the same x value out of the function, and I can connect those dots from my trials with a straight line. Just having 5 data points isn't enough to determine what the function actually is, but based on this, my best guess is this is probably the function g of x equals x. Let's look at a new function, h of x. When we're looking at h of x this time, let's pay particularly close attention to figure out if h of x is a function. Remember, a function is something that for every input, you get a correspondingly unique output, one and only one output for each input. Let's give this a try. Victor, you got an input for me? Let's try 1. h of 1 gives me a value of, let's see, 3. h of 1 is 3. Let's try another one. 2. h of 2 is 3 again. Let's try another. Plug in 3. h of 3 is, let's see, 3. h of 3 is 3. Let's plug in 7 now. h of 7 is 3. I think you're seeing a pattern here. Let's try one more just to be sure. h of 8, when we plug in 8, what do we get? Well, I'm not sure this time. 3. h of 8 is 3. This function seems to have, for every input, we get a value of 3. Does this contradict the definition of function? What do you think? It doesn't contradict it. It actually is a function. It kind of seems like it's not. Let's see why. The function we just saw, h of x, gave us an output of 3 no matter what the input was. If we graph this function, you notice all of the points lie in a horizontal line. A lot of students get confused and think that this isn't a function because all the values were the same. However, notice that we did get this, for each input, there was only one output. It wasn't like I put in a number and got 2 different outputs. So this actually is a function. The function value that it is h of x equals 3. No matter what number I input, the output is always 3, and the graph of this function looks like a horizontal line. Let's try one last function, r of t. Notice that my variable in this case, for the input, is t. Normally we use x, but there's nothing special about x. We just tend to use that a lot in mathematics, but the variable could be any letter. In this case, our function is r is a function of t. Let's go ahead and try out some values. Victor, you got an input for me? Let's try 2. r of 2 is pi. Let's try another one. 0. Let's plug in 0. r of 0 is scissors. Let's try one more. Let's put in a peep. r of a chicken is, let's see here, what do we got? A bunny. Let's try another one. Okay, let's input red. r of red is blue. So we put in some values to our function r of t. Victor, up till now, does it look like this is a function? Sure seems like it's a function so far, but to test this, let's try putting in one of the inputs we've already tried. Can I have a chick again? Last time when I put a chick in, I got a bunny. Let's see what happens this time. I'll put my chick into my function, and out comes a sock. One time I put in a chick and I got a bunny. Another time I got a dirty sock. This is an example of something that is not a function. Do you think it's a function now, Victor? No. This isn't a function because sometimes you put in a chicken, you got a bunny. Other times you got a sock. In the example we just did, the function r of t was looking pretty good to start out with. For each number I put in, or each object I put in, I got a unique output. But then, when I tried chick again, one time I got bunny, and the second time I got sock. So for this input, I got 2 different outputs. Let's remind ourselves what the definition of function was. A function is a correspondence between 2 sets of elements such that for each element in the first set, there corresponds one and only one element of the second set. The example we just tried violates this definition because sometimes for chick I got a bunny, sometimes I got a sock. You shouldn't think that these things that aren't functions are very exotic, strange things that you would never encounter. A lot of the things we deal with in mathematics aren't functions. For example, circles are not typically functions because it's possible to have a circle where you put in one x value and you get 2 different y values. For example, a circle with radius 1, when you plug in x, you might get y equals 1, or you might get y equals -1. So it's not a function. Let's go ahead and talk about the domain and range of these objects that we've been dealing with, these functions. Back to our function. The domain is a set of things we're allowed to put into the function. What are the allowable inputs to our function? So I input a domain, and the things I get out of the function, the outputs, are my range. So the domain is the inputs, the range is the outputs. When looking for a domain, you usually want to think about what is allowed to be put into the function. Usual things we look for is, remember, you're never allowed to divide by 0, so we look for places where there's division by 0. We also know that you're not allowed to take the square root of a negative, so we look for places where you might be taking the square root of a negative. Those are 2 common examples of things we look for when finding the domain of a function. The range, we usually look to see what are the allowable outputs for the given domain. In this this unit on functions and graphs, you will learn to identify functions, that is, see whether it satisfies the rule that for each input there's one and only one output. You'll learn to evaluate functions. That's what we were doing with our box, but you'll be doing that symbolically and with graphs. For a given input, figuring out what the output value is. You'll be learning to find the domain and range of functions. What is the set of allowable inputs, and what are the corresponding outputs? You'll also graph and find equations for linear functions. Linear functions are a special type of function that are super important in mathematics and come up quite a lot. Linear equations are equations of the form f of x equals mx plus b. The graph of these functions are straight lines with various slopes m. M represents the slope, or how steep this linear function is. The domain and range for the linear functions are unique in that they're both all real numbers. So you can put any real number in, you can get any real number out. You'll also learn how to find the line, the slope of the line, and the x and y intercepts of a given line in order to help you graph it. Other things you'll learn in this unit are to perform transformations of graphs. Transformations of graphs basically mean you'll start with a standard graph that you know. For example, the parabola graph is a common one you might already know. And you'll learn what happens when you do slight changes to it. For example, adding 2 to the parabola, x squared, moves the graph up 2 units. Subtracting 3, x minus 3, and then squaring it causes the graph to move 3 units to the side. We could also do things like stretch or expand our graph. For example, we have the graph here of 5x squared, which causes a vertical stretching of my graph. Another thing I could do is multiply by a negative number. If I look at f of x equals negative x squared, it causes my graph to reflect or give the mirror image over the x-axis. You'll be learning about these sorts of transformations in the coming unit. When talking about combinations of functions, you'll learn to do things like f plus g, f minus g, f times g, f divided by g, and something called composition. F composed with g means we do g of x first, and then we do f to the resulting output from g. It's basically like having 2 of my machine function boxes in a row, where one feeds into the other, and then you get an output after you've done both systems together. The last thing you'll be learning about is determining if a function is invertible and finding its inverse. Inverse functions basically let you go forwards and backwards to recover the original input. There's a lot of applications of functions. Basically, the applications of functions are everything around you. For example, if you're running, you might have a function of the amount of calories you burn as a function of the distance you've run. When you put your money in a bank, in an investment, you usually have a function of the amount of money you make as a function of the interest rate, or the amount of money you make as a function of the time you've left that investment in the bank. Well, have fun exploring functions. Thank you, and I'll see you next time.